Problem set number 4, question number 9. In this question, we are asked to solve for a sample size given a normal distribution. So the normal distribution is a requirement of this question because t distributions require degrees of freedom, and degrees of freedom require sample sizes, and we don't have one of those yet. So we're stuck using the normal distribution. To solve this kind of equation, it's generally best to start at the end, start with what we need, and work our way backwards. We need a sample size. We need an n, so we should find some equation that has an n in it, and then later we can work from that and solve for n. One possibility, and the one that we're actually going to use, is the standard error. So the standard error is the standard deviation divided by square root of n. So there's our n. And that is ultimately what we'll solve for. Fortunately, the question does not automatically, or unfortunately for you guys, the question does not automatically give you the standard error, nor can you use the standard error that you have been using, because that standard error already presupposed an n of 3. There were 3 data points, but now we have to solve for n, so we don't have a given standard error yet. We'll ultimately want that, and we'll ultimately calculate that, but we have to take another step back first and find a different equation that has a standard error in it. We have one of those also, and that is the confidence interval equation. The confidence interval equation is the sample mean plus or minus the critical value times the standard error. Now, as noted above, the confidence interval, even though I have it here as a single variable, the confidence interval is actually 2 values. There's a lower bound and an upper bound. That comes from this plus and minus on the other side of the equation. Visually, it's something kind of like this. We have the lower bound over here, and we have an upper bound over here. So to calculate the lower bound, we take the sample mean, and we subtract the CV times the SE, so times the standard error. So we start at the sample mean, and we subtract the critical value times the standard error. Well, that should tell us something. If we start from the sample mean and we're going this way, this distance is equal to this. We started at the sample mean, and we subtracted critical value times the standard error, and that gave us this lower bound. So this value should equal this. And we don't have to worry about the sample mean in this case. The sample mean could be 0, it could be 2, 200, 2000. It has no effect on how wide the confidence interval is. The width of the confidence interval is only determined by the critical value times the standard error. Similarly, for the upper bound is the sample mean plus the critical value times the standard error. So the critical value the sample mean start there and move out a distance equal to the critical value times the standard error. If we look in the question, it tells us that we are looking for a width of the confidence interval, a width from the mean, distance from the mean, equal to 5. So it could be plus 5, it could be minus 5. We just needed to be within 5 total. So from this, going from the mean out 5 units to our upper bound means starting here, starting from the mean, we're going to go critical value times the standard error has to equal 5. So 5 is going to equal the critical value times the standard error. And I realize my 5 looks a lot like an S. That is the number 5. So we've kind of simplified this equation. We're one step closer. We can do another substitution where 5, I'll try and write it a little neater this time, is equal to the critical value times the standard deviation divided by the square root of n. So we're just taking this and substituting that into it. We ultimately want to solve for n. We're not quite there yet. We don't have a critical value, and we need one of those. So if we think back to what we've been doing previously and how normal curves work with hypothesis tests, a critical value is a threshold. And let me actually draw that in the right place, because now it kind of matters. It has to be exactly on top of the, on top of, sorry, I just had a cat walk in front of me, so I couldn't see what I was doing. The critical value has to be exactly the same limits as the confidence interval. Remember, the critical value is in standard error units in this case, and the confidence interval is the same distance, but in original data units. But location-wise, they have to be in the same place. The critical value was defined such that we have a certain probability over here, a certain area under the curve, and a certain probability, area under the curve, on this side. And the distance, or the area in between the two critical values, that was our confidence level. And 1 minus the confidence level is equal to the significance level. Because we have some space over here and we have some space over here in our rejection regions, the significance level, which was still 0.1 in this question, we divide into 2. And so we have, do that a little bit better, we have 0.05 on this side, and we have 0.05 on this side. And so the critical value, and the critical value here, which I'll put with a negative sign, is defined as the number of standard errors away from the mean that gives us this probability, the significance level divided by 2, since we're talking about a two-tailed situation. Excel will calculate this for us just like it has in the past. We have a slightly different function in Excel because this is a normal distribution and not a t-distribution. But the syntax is rather similar. So we start off with norm because it's a normal distribution. We have the .inv, the inverse, because we are going to give Excel a probability. We know this value. And we want a distance out of it that we don't know, but that's what we want. So we give Excel a probability and get out a distance. In this case, the probability is 0.95. Our confidence level was 0.1. So our significance, our confidence level is 0.9. That means our significance level is 0.1. Divide that into 2 means this side is 0.05. I asked Excel to give me the area under the curve from negative infinity up to here. So it would be a number that I could understand readily. It's just the way my brain works. So this area from negative infinity up to here is 0.95, which leaves 0.05 on the other side. And so Excel will tell us that the distance from the mean to that critical value is 1.64 standard errors. The Excel slides did mention that you need to use the .s function in here. The .s means that we don't have a given value for the mean, and we don't have a given value for a standard deviation. We don't have a given value for a standard error. For this kind of question, we don't need any of those. The normal curve has very defined properties, and it doesn't matter what the mean or the spread is. There's the number of standard errors to leave a probability of 0.05 is always 1.64. It is a standard number, and so we can use the .s, a standard normal distribution, to get this. I guess practically speaking, the way you could figure that out if you didn't have access to the slides was to ignore the s, and it'll ask you for a mean and a standard deviation, and we don't have those. So if you put in the s, all you are required to give it is a probability, and we do have a probability. So that means we're using the right function. Okay, so we have a critical value that gives us the probability we are asking for. So that tells us how far this needs to be in standard error units. That is 1.64. So now we can do another substitution in here. Scoot this down. We now have 5 is equal to 1.64 times the standard deviation over the square root of n. It was probably actually easier if we don't do this part yet. Let's just leave that as the standard error. So we have a number here, and a variable here. So we can solve for the standard error now. The standard error is going to be equal to 5 divided by 1.64. It's getting harder and harder to write with the mouse. and we have solved for that up here. The standard error is equal to 5 divided by 1.64, and that gives us 3, or 3.04. So now the standard error is so one more equation. So now we're kind of working forwards, working towards n. The standard error is equal to the standard deviation divided by the square root of n. We just calculated the standard error as being 3.03, maybe it was 3.04, 3.04 as it turns out. That's why we do this in Excel and not by hand. So 3.04 is equal to the standard deviation. So the standard deviation does come from our data. That is 13 point, whatever the standard deviation was supposed to be, 13.89 that we just calculated, I think, way back in one of the earlier problems over the square root of n. So now again, we have one equation with one unknown, so we can solve for the square root of n and take the square of that, solve for n directly. N is equal to the standard deviation, which is 13.89, divided by the standard error, which we calculated earlier as 3.04. I guess I have 3.03 here, it should be 3.04. Square that, and we get an n of about 21. And that is how we do that.